What is a galaxy? A galaxy is any of the systems of stars and interstellar matter that make up the universe. Many such assemblages are so enormous that they contain hundreds of billions of stars. Galaxies usually exist in clusters, some of which measure hundreds of millions of light-years across. Are all galaxies the same shape? Galaxies differ in shape, with variations resulting from how the systems were formed and subsequently evolved. Galaxies are extremely varied not only in structure but also in the amount of activity observed. What are the types of galaxies? Galaxy classification is based on the scheme proposed by the American astronomer Edwin Hubble. Hubble's scheme is based on the optical appearance of galaxy images and divided into three general classes: ellipticals, spirals, and irregulars. Galaxy, any of the billions of systems of stars and interstellar matter that make up the universe. Galaxies vary considerably in size, composition, structure, and activity, but nearly all are arranged in groups, or clusters, containing from a few galaxies to as many as 10,000. Each is composed of millions to trillions of stars. In many, as in the Milky Way galaxy, nebulae can be detected. A large fraction of the bright galaxies in the sky are spiral galaxies, with a main disk in which spiral arms wind out from the center. The arms contain the greatest concentration of a spiral galaxy's interstellar gas and dust, where stars can form. Surrounding the center nucleus is a large, usually nearly spherical nuclear bulge. Outside this and the disk is a sparse, more or less spherical galactic halo. In elliptical galaxies, which vary greatly in size, stars are distributed symmetrically in a spherical or spheroidal shape. Dwarf ellipticals, with only a few million stars, are by far the most common kind of galaxy, though none is conspicuous in the sky. Irregular galaxies, such as the Magellanic Clouds, are relatively rare. Radio galaxies are very strong sources of radio waves. Seyfert galaxies, with extremely bright nuclei, often emit radio waves and may be related to quasars. Galaxy, any of the systems of stars and interstellar matter that make up the universe. Many such assemblages are so enormous that they contain hundreds of billions of stars. Nature has provided an immensely varied array of galaxies, ranging from faint, diffuse dwarf objects to brilliant spiral-shaped giants. Virtually all galaxies appear to have been formed soon after the universe began, and they pervade space, even into the depths of the farthest reaches penetrated by powerful modern telescopes. Galaxies usually exist in clusters, some of which in turn are grouped into larger clusters that measure hundreds of millions of light-years across. A light-year is the distance traversed by a light in 1 year, traveling at a velocity of 300,000 kilometers per second, or 650 million miles per hour. These so-called superclusters are separated by nearly empty voids, and this causes the gross structure of the universe to look somewhat like a network of sheets and chains of galaxies. Galaxies differ from one another in shape, with variations resulting from the way in which the systems were formed and subsequently evolved. Galaxies are extremely varied not only in structure but also in the amount of activity observed. Some are the sites of vigorous star formation, with its attendant glowing gas and clouds of dust and molecular complexes. Others, by contrast, are quiescent, having long ago ceased to form new stars. Perhaps the most conspicuous activity in galaxies occurs in their nuclei, where evidence suggests that in many cases supermassive objects, probably black holes, lurk. These central black holes apparently formed several billion years ago. They are now observed forming in galaxies at large distances as brilliant objects called quasars. The existence of galaxies was not recognized until the early 20th century. Since then, however, galaxies have become one of the focal points of astronomical investigation. The notable developments and achievements in the study of galaxies are surveyed here. Included in the discussion are the external galaxies, i.e., those lying outside the Milky Way galaxy, the local galaxy to which the Sun and Earth belong, their distribution in clusters and superclusters, and the evolution of galaxies and quasars. The dispute over the nature of what were once termed spiral nebulae stands as one of the most significant in the development of astronomy. On this dispute hinged the question of the magnitude of the universe. Were we confined to a single, limited stellar system that lay embedded alone in empty space, or was our Milky Way galaxy just one of millions of galaxies that pervaded space, stretching beyond the vast distances probed by our most powerful telescopes? How this question arose, and how it was resolved, is an important element in the development of our prevailing view of the universe. Up until 1925, spiral nebulae and their related forms had uncertain status. Some scientists, notably Heber D. Curtis of the United States and Knut Lundmark of Sweden, argued that they might be remote aggregates of stars similar in size to the Milky Way galaxy. Centuries earlier, the German philosopher Immanuel Kant, among others, had suggested much the same idea, but that was long before the tools were available to actually measure distances, and thus prove it. During the early 1920s, astronomers were divided. Although some deduced that spiral nebulae were actually extragalactic star systems, there was evidence that convinced many that such nebulae were local clouds of material, possibly new solar systems in the process of forming.